So today we proceed and we're looking at covalent bonding. So basically with covalent bonding, this is where elements or atoms rather, they are going to come together and they are going to form a bond. Now, the characteristic thing about covalent bonding is that it involves the sharing of electrons. Remember what we said about ionic bonding. Ionic bonding involves the what? The transfer of electrons. And so what basically happens in covalent bonding is that usually you are going to have what? Non-metals. Why is it non-metals? Because non-metals are better off receiving electrons. Okay, so when they're reacting with a metal, it's easy, okay, because they'll go via the route of what? Ionic bonding. But when it comes a non-metal and a non-metal, since they both want to gain, okay, they both want to gain electrons because they tend to have a high electronegativity. So electronegativity, this is the tendency of an atom or an element to attract electrons towards itself. So because non-metals have got a high electronegativity, that means that they will always want to what? To attract electrons to themselves. And so for them to give out, it becomes hard. Therefore, when non-metals are what's this, they want to form a bond. And remember, like we said in the previous video, we said the reason why element or rather atoms want to bond, it's because they want to fulfill either the duet rule, such as for for hydrogen, where they want to have two electrons in the outermost shell, so or the way helium is, or it's the octet rule, which means octet means 8, like I explained in the last video. So octets, that they want to have 8 electrons in the outermost shell. That's when they'll be stable. Okay, so what that means is that if you've got let's say an atom such as chlorine, it's got 7 outermost electrons, so it wants to gain another one, okay, for it to be stable. So same as oxygen, it wants to gain 2 for it to be stable because it's got 6. So that's really the key thing. And so when we talk about hydrogen, so we're going to talk about uh, two types of covalent bonds, and these are going to be non-polar and polar covalent bonds. Now, what does this polarity mean? Well, remember I mentioned something about electronegativity. Okay, so what happens is, and we'll discuss this more in chemistry, but just for you to have a good picture, is that what happens with electronegativity, remember I said this is the tendency of an atom to pull electrons towards itself, right? And so what happens when you go to the right of the periodic table, you are having what? Non-metals, isn't it? And the left side has got metals, right? So the general rule is that as you go to the right of the periodic table, electronegativity what? Increases. As you go to the left, it decreases. Then when you go down a group, so let's say you are in, let's say, a particular group of the periodic table, as you go down the group of that particular or rather on the periodic table, you're going to find that electronegativity is going to what? To decrease. Reason being is that as you go down a group, and we'll discuss this more in chemistry, but as you go down a group, what happens is that more electron shells are being added to that particular atom, and so that decreases the attractive ability of the what? The attractive ability of the nucleus, right? And so in reducing its ability to pull electrons to itself, from the other things that's trying to react with. So that's about it. So now, when you talk about polar covalent bonds, what we're basically talking about, these are covalent bonds, electrons are shared, but because the difference in the electronegativity of the reacting atoms, the difference is not large enough, therefore electrons are going to be shared equally. So for instance, let's look at this example with hydrogen there. You see there is one hydrogen there, and so after that you can see that the electrons have been shared to form the hydrogen molecule, and that's the duet rule, because now each hydrogen has got two electrons, so they are now both stable. Right now, when you look at this is hydrogen and hydrogen, so they are same. In other ways, we can say they've got the same electronegativity, right? Because it's the same atom. So what's their difference? The difference in electronegativity is what? Is zero. So the electrons are going to be shared equally. They won't be put more on either side. No, they will just be shared equally. Or if you want to put it in another way, they'll be on the middle of the two atoms. Right now, when we talk about also another thing, carbon and hydrogen, so this particular compound, you can call it carbon tetrahydride. But when you do organic chemistry, this is what we call methane. So what basically here is happening is that here you've got carbon. Now remember, carbon has got what? Four outermost electrons. And remember, for the duet rule, for it to have two outermost electrons to be stable, it only applies to hydrogen and helium. So for the other elements, it's going to be the octet rule. So for carbon to be stable according to the octet rule, what has to happen? What has to happen is that it needs to gain four more electrons, right, for it to be stable. So how does this happen? So if carbon is put close to hydrogen, or it's made to react with hydrogen, remember, hydrogen is going to give what? Is going to be giving one electron at a time. So how many atoms of hydrogen do you expect to have? Four, right? But then what if it's reacting with oxygen, for instance? Remember, oxygen, you know, that's a different dynamic. But you realize that because hydrogen has got pretty much more electrons in its outermost shell, that's why you realize that when you want to do things such as carbon dioxide, you know, you have two oxygen atoms, so things like that, right? So now the key thing here is, see that the those covalent bonds have been formed, and you can, when you count the number of electrons outside of the hydrogen, you can tell that there are two, right? And for the outermost shell of the carbon, when you count 2, 4, 6, 8, you can see it's six, rather 8 electrons. So you can see that for the oxygen, the duet rule has been done, or has been fulfilled, and for the carbon as well, the octet rule has been fulfilled. So that's our structure there. Now, the thing is that when you look at carbon and hydrogen, they are both non-metals, right? And so since they are both non-metals, the electronegativity, the difference is going to be small. So their electrons, okay, are going to be shared midway. Of course, when we look at when we go deep in chemistry, we'll be able to look at the actual values, the difference, the ranges. But for biology, what you just want to understand is that when you go to the periodic table, look at where hydrogen is, look at where carbon is, you realize that the electronegativities are what? uh, are both low, and if they are low, their difference is going to be low. Now when we talk about covalent bonds, polar covalent bonds actually, so what you're basically having, the best example is for the molecule water, right? So or maybe before we can talk about water, let's talk about something smaller. Think of hydrogen chloride. So hydrogen chloride is when you've got hydrogen and chlorine. Now, one thing you have to know is that the hydrogen has got a very low electronegativity, and the halogens, chlorine, bromide, they are very electronegative. So what's going to happen is, because, and remember, it makes sense, right? Because the halogens are very far right of the periodic table, so it makes sense, right? So now what's going to happen is that even when they form that bond between hydrogen and chlorine, what's going to happen is, because of the high electronegativity of chlorine, most of the electrons are going to be put towards the chlorine atom. And because they are going to be put towards the chlorine atom, you are going to realize that there will be a slightly negative charge on the chlorine and a slightly positive charge on the hydrogen. Perfect. So a slightly positive charge on the hydrogen. So now that's the same concept that we're having here for water. So you've got oxygen and two hydrogen atoms. So you see again here, oxygen goes by the duet rule, yes, and then oxygen goes by the octet rule. So again, when you see oxygen has got 6 electrons in its outermost shell. So how many more electrons does it need to gain? Two. Yes, you guessed right. So two electrons, right? And they are, how can we get those from hydrogen? So we need two hydrogen atoms, because each hydrogen atom can only give us one electron at a time. So that's why we are going to have those two hydrogen atoms. So when you see here again, you see that the octet and the duet rules have been fulfilled. The duet rule, of course, for hydrogen atoms, and then the octet rule for the oxygen. Then you see now, like the example that I gave about hydrogen chloride, you see that what's this? So you see that even though the bonds have been formed, and all the rules octet and duet have been fulfilled. But then again, we come back to the concept. Oxygen is very far to the right of the periodic table, so that tells us what? High electronegativity. We'll talk about the actual values in chemistry. So now, because of the difference in electronegativity is very large, so most of the electrons are going to be put where? Towards the oxygen side. So what's going to happen is that even though the electrons are shared, they are not shared equally. That's the thing about polar covalent bonds. The electrons are not shared equally. So the part where electrons are more, or the side to which they are going the most, that's the side that's going to be slightly negative. Then the ones where the distance is much larger, they are the ones where they're going to be what? Slightly positive. Like you can see there, or on the oxygen molecule, you see that rather in the water molecule, you see that oxygen is slightly negative, and then the two hydrogen atoms are slightly positive. And it is this concept that gives water its interesting properties, but we'll talk about those. Yeah, so these notes are basically explaining everything that I've just explained, but I wanted to use the pictures, and because they are more helpful. So that's really about. So the next part we'll talk about hydrogen bonds. So thank you very much, and if you've got any questions, please drop them in the comment section, and I'll respond to them.